Picking right back up on page 8 of your notes packet, describe some of the factors that will influence climate. The first one is latitude, which is degrees north or south of the equator. So these are the lines that wrap around the Earth horizontally. So the further from the equator you get, either north or south, the cooler it's getting. And that latitude will have similar conditions wrapping all the way around the globe, as we've seen with the variations in pressure and therefore general climate, whether it's wet or dry. Topography just means changes in elevation. Just like when we drive up to Flagstaff, it gets a heck of a lot cooler. That's because the higher you get, the cooler it is. In addition to that, very high areas can actually create their own weather, and you can have a very different climate on one side of the mountain versus the other. So, topography can actually create its own weather. So, we'll be looking at an example of that in just a minute with the Himalaya Mountains. Because with a very high elevation, you have a low pressure, because there's not much atmosphere sitting on top of it. It sort of sucks in the air from other places. It pulls the wind in from lower elevations. So topography plays a big part. Water bodies. Water heats up slowly and releases heat slowly, as opposed to land, which heats up quickly and in most cases releases heat quickly. So this is land, natural land, not man-made stuff, okay? So water retains heat and releases it slowly. So an example of that would be if it has been a really cold stretch. It's been a few days of being really chilly, and you go to put your feet in a pool. Even though that day it may be really warm, the water's still going to be cold because it heats up slowly. And the opposite is true as well. If it's been a really hot day, even if it cools off at night, that water is still going to be warm at night. And this plays a big part in climate because it regulates the temperature. It acts like a buffer. Size of the city. Bigger cities produce more heat. So this gets into sort of the heat island effect, and we'll go into that more in the next one. Land cover. Concrete absorbs more heat than grass. So what I mean by that is if you are driving through town and you dip into a wash, right? You go through a little valley. It's going to be much cooler in that little wash where you don't have anything built than it will in the surrounding area. Just like in the summertime, you would rather walk barefoot on the grass than you would on the hot concrete for this very reason. So the more concrete you have, the more asphalt you have, the hotter it gets. And larger cities with a lot of this stuff start to hold on to that heat. And over time, it's harder and harder for that heat to be released. And so you get the heat island effect, which means over time, the temperature in a very specific location, like a city, is going up. Pollution emissions. Smog and ozone can really affect the climate. You can either have a greenhouse effect kind of thing going on, where you've got gases that don't allow the heat to escape, and so the climate is heating up, or you can have things like soot, particulates, pieces of things, um, even volcanic ash that are blocking the sunlight, and so you get what's called a dimming effect, and temperatures decrease. So pollution affects climate as far as temperature. It also affects it in other ways depending on what sort of pollutant you're dealing with. You can get acid rain and that kind of thing. And the last one is number of people. So this may not be something that comes to mind for you when you're thinking about factors that influence climate, but if you think about a very crowded elevator in the summertime, the more people you have in there, the warmer it is. And the more people you have, the more potential pollution emissions you have, the more land that gets covered with housing and things that people need. So number of people really affects the climate. Ocean currents influence climate in a very, very significant way. Really, they're regulating the Earth's climate, and it's pretty cool. So, how does ocean circulation regulate heat? The first thing is it's moving warm water at the equator to the poles. You have shallow surface currents that are driven mostly by wind, and they move their way always to the left and then down to the pole. Okay, so in the southern hemisphere, we get that counterclockwise rotation from the Coriolis effect, and in the northern hemisphere, we get the clockwise rotation. Okay, so it goes to the left along the equator because of the rotation of the Earth, and then once it hits land or some sort of obstacle, then it veers towards the pole, whether in the northern hemisphere it veers to the north, or in the southern hemisphere where it veers to the south. Okay, ocean surface currents. So ocean surface currents extend down about 1,000 meters. That's what I mean by when I say shallow surface current, about 1,000 meters down. Most are shallower, fast-moving streams driven by the prevailing winds, as I said. In this image, the black lines indicate relatively cool surface water, while the red lines indicate currents that are warm. Surface currents greatly affect climate along continental boundaries. So in an area where it is receiving a lot of sunlight, you can cool things off. You can regulate the temperature by bringing in a cooler current. Likewise, in a very cold place, at a more polar latitude, you can warm things up by bringing in a warmer current. Why are some currents warm and other currents cold? Warm currents flow off of the equatorial currents toward the North and South Pole. The equatorial currents are warm because they're receiving the most direct sunlight. Okay, that's that differential heating thing we talked about last time. They lose heat along the way and change to cold currents as they circulate back toward the equator. Okay, deep ocean currents. This image is dealing with deep ocean currents. It shows the thermohaline conveyor belt, which is a recycling flow of water through all of the Earth's main oceans. You have deep currents shown in blue arrows. They are slow and travel along the floors of the ocean basins. The deep currents begin in the North Atlantic, where warm, salty water from the Gulf Stream is cooled by prevailing winds. The cold, extra salty water is much denser than the cold waters of the North Atlantic, and it sinks to the ocean basin floor. So this is what is driving the entire thermohaline conveyor belt. We've got this cold, salty water in the North Atlantic that sinks down extremely fast um, and gets everything moving. Okay, this cold flow traverses the blue arrow path that's shown on this figure, and then rising in the North Pacific some 1,000 years later. Okay, so this is a fairly slow process working its way all the way through the Earth's ocean, but it does make its way all the way through. So what does the thermohaline conveyor do? The deep ocean current flow is called the thermohaline conveyor. It circulates deep ocean water because of differences in temperature and salinity. Okay, so this brings back in convection. Cold material sinks, hot material rises. And so when we bring in the salinity factor, how salty is the water, the saltier it is, the more dense it is, and so it's going to sink down. Water that is cold or has lots of salt is denser than water that is warm and has less salt. Alright, ocean currents affect land temperature. So I hinted at this a second ago, but in this image we have the warm East Australian current that evaporates vapor carried by prevailing winds to the eastern coast of Australia. Okay, so warm currents are bringing warm, moist air to the land, changing the temperature to be cooler in dry desert areas. So if we look at the eastern portion of Australia, the east coast there, it is greener than the inland area. Winds blowing across the warm Gulf Stream help moderate temperatures across Europe. That's what we're looking at here. Okay, the Gulf Stream comes up along our east coast, and then it's bringing warm water up to Europe. It cools off, and it sinks back down. Okay, so big currents like the Gulf Stream carry enough moisture to help moderate land temperatures and bring moisture to northern Europe, influencing its temperature. And this plays a big part in why a lot of Western Europe is as warm as it is as temperate as it is, which makes it quite livable. It has happened in the past where the Gulf Stream has been cut off in human history. And when that happened, it sent Europe into another mini ice age because they didn't have that warm current coming up and regulating the temperature there. So ocean currents affect land precipitation. In this image, we want to observe how currents affect precipitation on land. These names here are just the names of the current. So on the left, we have the Humboldt Current, which forms an arid region along the west coast of South America. So it's blue, meaning it's cold. So we're not getting a lot of precipitation there. If your water is cold, how are you going to have evaporation take place so that you can create the clouds, right? So cold currents means drier area. The Brazil Current provides abundant water vapor and moderates the climate along its coast. So on the east coast of South America, they have much higher precipitation, and this is where we find the rainforests of Brazil, because we have this Brazil Current coming through and keeping everything very humid. The Benguela Current that is moving along the southwestern area of Africa is also forming an arid region in southwestern Africa because, again, it's a blue current. You don't have the moisture in a cold current. Okay, so how do warm currents and cold currents affect precipitation on land? Okay, having just gone through all of that, hopefully you understand that where a warm current borders a continent, it causes humid climates and high rainfall. Cold ocean currents can result in arid regions. Okay, so again, arid regions just means it's dry, it's desert. We live in an arid region. And which side of South Africa has a warm ocean current? Okay, so we're looking at Africa on the right here. We've got the Benguela on the left, on the west coast. We've got the Mozambique on the right, on the east coast. So which one of those is warm? We have the east side, right? Because these orange arrows indicate that it is a warm current. So how does that affect the climate? We have more moisture and higher temperatures. And how does this compare to the other side of South Africa? Okay, we already said the Benguela cold current is not providing any moisture, so it is a more desert and arid landscape. El Niño and La Niña. El Niño and La Niña are the end-member effects of the strength of the Pacific equatorial countercurrent, which flows east across the Pacific toward South America. Okay, this image here, we're looking at El Niño. El Niño occurs when the current is strong and extends warm water to the eastern Pacific, leading to increased evaporation and increased precipitation on land. And I've got a little video here if you want to click on that and get a little more information or a different way to look at this. When we have an El Niño, this causes more rainfall in the southwest for us and warmer than normal winters in the Midwest. Okay, this is the La Niña effect. So with La Niña, that occurs when the current is weaker and the ocean water temperatures in the eastern Pacific are cool, causing drier conditions on land. Okay, so in this case, all of the warm water is piling up near Japan, near Australia. Okay, and when that happens, we get cooler water over near us, and that results in relatively drier and warmer winters in the south and in the, wet winters in the northwest, the Pacific Northwest. What causes short-term climate variations? So our first example here is a monsoon. All a monsoon means is it is a change in wind direction from one season to another. So when we think of monsoons, we think of it as an actual storm, but what it is really is just a change in wind direction. Okay, the best example of a monsoon is in India. The high Gobi Desert becomes a center of low pressure every summer as warm air rises from the heated lands. Vapor-rich air from the Arabian Sea and Bay of Bengal flows inward toward the low-pressure zone, bringing seasonal rains. As the vapor-rich air rises over the Himalayas, massive rainstorms occur. Okay, so they've got two seasons, a dry season in the winter and a rainy season in the summer, and it has to do entirely with the elevation here. Okay, so around the coast of India at sea level, it's got a much higher pressure. And up in the Himalayas, because it's at such a high elevation, you've got a much lower pressure. So remember, air always wants to flow from high pressure to low pressure, so you get this huge shift in the summertime where wind starts blowing in off of the ocean up into the mountains. Moist air hits the Himalayas, where it rises and cools, forming massive rainfall. And that's only after the warm, moist air flows inward toward the low pressure, increasing rainfall. Okay, so what happens? How does this affect their climate? During the dry season, very little rainfall occurs and all the vegetation dies. Okay, so, excuse me, the dry season is rough. Okay, but during the rainy season, you might think, oh, wow, that sounds great, because I know when it rains here, I get pretty darn excited. But during the rainy season, an immense amount of rain falls. It's just a huge amount of rain. And that floods many regions, and it turns the country green with new vegetation growth, but at the same time, it can do a lot of destruction as well. So pay attention to this. When the rainy season hits, when the summer hits, you'll hear about major floods in India, and usually in Pakistan too. Okay, and it's all part of this interaction between the very high topographic high of the Himalaya Mountains and the low, warm, moist air at sea level here. What causes a drought? We've got a few different things that can cause a drought. Drought is just an extended period of below average precipitation. Okay, so below average for that area. So our drought would be different than a drought in the rainforest, right? A drought in the rainforest, they could still be getting quite a lot more rain than we get, but because it's below their average, that's considered a drought. All right? A persistent weather pattern or change in ocean currents can cause an unusual shift in wind direction. Okay? So if you had, like we were just looking at India, if you have warm, moist air coming in off of the ocean, and then suddenly that wind pattern changes and starts blowing inland out toward the ocean, you're going to miss that rainy season altogether, right? Because you need the warm, moist air coming in and going up to higher elevation to cool and condense and rain. So that's one way, an unusual shift in wind direction. Okay, the next one is persistent high pressure. With its sinking air, it can cause a region to be drier than normal. Okay, and we get quite a lot of persistent high pressure here. But once the low pressure systems come in, then it brings in with it storms and rain. And a lot of times, you hear, maybe you've heard your grandparents or someone complain about the weather change and how it, they can feel it coming. That's real, because we can feel the pressure of the air all around us, even if we're not always aware of it. So you might get a little headache, you might get a little achy, something like that when a low pressure system's coming in, because you've been under all of this pressure of the atmosphere pressing down on you, and when that's released, things change. Okay, the last one there, a temporary change in the direction or strength of an ocean current that can last multiple years. So if you had a warm current coming through that was providing moisture to that area, and suddenly you have a cold current coming through, that will change things drastically. With the cold current, you won't have the evaporation, so the air will be very dry. This brings us to some areas of climate extremes. So the first one we're going to discuss is the rainforest. Before we can talk about the rainforest, we need to define what it is. So what is a rainforest? It is a forest with high annual rainfall, no freezing temperatures, and a rich collection of plant and animal communities. Rainforests are extremely lush environments and are critical ecosystems since they contain more than half of the terrestrial life on Earth. Rainforests occur in the tropics and are associated with the Intertropical Convergence Zone, also called the ITCZ, a line along the equator where the northeast and southwest trade winds converge. The location of the ITCZ brings low pressure and immense rainfall. So you can see the location. The orange is the location of it in the northern hemisphere. The light blue line is the location of it in the southern hemisphere. And so it changes with the seasons. In the wintertime, in our wintertime, it moves down south of the equator. In our summertime, it moves up north of the equator, depending on which pole is more oriented away from the sun. So the ITCZ is going to change based on seasons, and it is going to rely entirely on the trade winds, because again, it's where the northeast and the southwest trade winds converge. Why are rainforests disappearing? So there are several reasons that we're going to talk about in this class. The first one is commercial logging. Commercial logging consumes large areas of rainforest and generally involves clear cutting, meaning you're cutting down everything. No trees left. The next one is natural resource exploitation. Finding and removing natural resources such as copper and oil destroys tracts of rainforest. So if you've got a big mine, you've not only just cut down the forest there, but you've dug a big hole. So you've destroyed the soil that was there that could support a rainforest in the future. The next one is cattle ranchers. This isn't a very intuitive one, right? This isn't the first thing that comes to your mind, but it's quite a big deal. They remove rainforests to make space for pasture grasses, right? You can't imagine cows roaming around through very dense rainforests. No, they clear cut the trees, and cows can go and graze on the flat patches. The next one is highway construction. Roads to support logging or other industry destroy that swatch of forest. The next one is dam construction. This provides hydroelectric power, which is great because you're not relying on fossil fuels, but at the same time it also destroys areas by forming a reservoir. So the way dam construction works is basically you're building a wall across a canyon, and so everything behind that wall floods. The last one is subsistence farming, where forests are cleared for farming, and at the same time they do what's called slash and burn. So not only do they cut it down, but they're burning things as well. The opposite extreme is deserts. So what is a desert? A desert is an arid region that receives less than 25 centimeters, that's about 10 inches, of rainfall per year. Vegetation is sparse, commonly covering less than 15% of the ground. Where do deserts and other arid lands occur? Deserts occur in areas where there's high pressure dominance. Okay, so if you think of the big subtropical deserts, okay, pointed out on this map, those are all occurring because of the descending air and high pressure, right? Remember, in order to have humidity in the air, you need warm, moist air rising up. But when you have high pressure, you have cooler, dry air sinking down. So that's going to give you desert conditions. They also occur near cold ocean currents and on the backside of mountains because of the rain shadow effect, meaning one side of the mountain, the windward side of the mountain, gets all of the rain, and then there's no moisture left by the time the air gets to the other side of the mountain. Also, the interior of continents is a big place for deserts, just because it is so far from sources of moisture. Desertification is the converting of regular land to desert conditions. This occurs because of extended periods of drought, overgrazing by livestock, poor farming techniques, and diversion of surface water. So this map is showing us areas that are experiencing this. Areas that are most at risk include Central Africa, the Middle East, and the U.S. Great Plains region. Okay, just to point out some more specifics here, I mentioned earlier in the lecture that you won't be changing the amount of rainfall by over-pumping groundwater. You'll just be changing the level that the water table is at. However, it can lead to desertification because to be a desert, that could be either the amount of rainfall or the amount of vegetation that's covering the land. So if we have overgrazing by livestock or if we have poor farming techniques, then we're eliminating vegetation. And with either of those, you can lose your topsoil. So the top layer of the ground, of soil, where anything is growing, is going to have a different level of nutrients. And so in areas that are really good for farming, you've got really good topsoil. So if you've overgrazed by livestock or you've used poor farming techniques and there aren't roots holding all of that topsoil in, then when a big wind comes along or a heavy rain, you can lose that topsoil, and that will lead to a very sparse vegetation cover. The same goes for diversion of surface water. If at the source of the Colorado River they decided to put a big dam in and not let any water go past, then everybody downstream would experience desertification because we would lose that surface water. All right, landscape features that are characteristic of deserts. We have alluvial fans. These are loose rocks transported from mountainous areas in streams and deposited in fan-shaped aprons. This image is in Death Valley, but we have these alluvial fans all over the valley. Anytime you have a steep slope going into a valley, you usually end up with an alluvial fan. Okay, desert washes. Normally dry, these washes can fill rapidly with water during a rainstorm. This image is of the Mojave Desert. But this is where flash floods occur for the most part. So you want to be sure that you're not in a wash if we've had any rain recently. Playas. Playas are shallow, closed basins that receive runoff but have no outlet. Oftentimes, these will be areas where water just sits and dries up in the desert. And so you can get what are called evaporite lakes. So as this water is evaporating, all of the minerals get concentrated and you can get big deposits of salt, you can get big deposits of gypsum. They can be really interesting environments. The next one is my favorite, sand dunes. These are formed by sand that is not held down by vegetation, as long as there is a sufficient supply of sand. So right now, some areas of the Navajo Nation are undergoing desertification by having dunes remobilized. So there used to be sand dunes, then they were covered by vegetation. Now they've been undergoing drought, not enough water, so the vegetation's died off, and the dunes are starting to move again. The next one is a satellite image that shows us all of these features. So we've got fans that are these V-shape features coming off of the mountains down into the valley towards the bottom of the image. Washes where it looks like there's water flowing through in the flat area, and then the rest of that flat area is a playa. Okay, other features that develop over time in deserts. The first one is called pediment. That's a gently sloping erosional surface. The next one is desert pavement. Rocks concentrated on the surface because finer materials have been blown or washed away. So it actually looks like somebody came in and paved this area or, sorted out all of the rocks, but that's not the case. It's just all of the small material that would have been in between has blown away. Caliche. If you've ever tried to dig yourself a garden or a hole for any reason in the desert, this is, you're probably familiar with caliche. It's soluble materials in water percolate down into the soil, and the water evaporates, so the minerals stay behind, coating any clasts that are there. So little bits of sand, little rocks, all get coated with this calcium carbonate. Desert varnish. Exposed surfaces in the desert get coated with iron and manganese oxides, forming dark, natural rock varnish. So if you walk around in the desert, some areas it looks like all of the rocks are black, and you may think to yourself, wow, I bet this is one big, basaltic eruption. But if you break those rocks open, you'll see that a lot of times just the outside of the rock is black and the inside is something else. And that's the case with desert varnish. The last one is natural stains. You get vertical streaks of red, brown, and black deposited by water that flowed down the rock face and then evaporated. That brings us to the next topic, which is global warming. So what do you already know about global warming? Okay, take a minute. What do you think? Okay, you've probably seen things on the news, you've read it in the newspaper, you've talked to people, you've seen movies. You've already got an idea of what global warming is and what it means. And you may have some sort of political spin on that. So what I want to do is explain the science behind it, and let's just get politics out of the way here. Okay, so let's define global warming. Global warming means increasing global atmospheric and oceanic temperatures from some point in the past to the present. Okay, these are just recorded temperatures. There's no doubt within the scientific community that this is occurring. The debate is over whether global warming is a result of natural events or a result of human activity. Past temperatures are inferred by types of observations referred to as proxy evidence. So we're going to go through a whole bunch of different proxy evidence so you can see just what they're talking about when they're talking about global warming. Okay, so a brief overview on what processes influence atmospheric temperature changes. Okay, the sun provides most of the energy that heats the Earth's atmosphere. The light interacts with the atmosphere, the land, and the oceans, either being reflected or absorbed. So you'll go through each of these little boxes here and see it's either being reflected or absorbed. Some of the energy is reflected back into space. Light energy absorbed by the land or the ocean may be re-emitted as infrared energy, which in turn is absorbed by greenhouse gases like carbon dioxide. Greenhouse gases heat up when absorbing infrared energy. So it acts like a blanket, basically, hanging on to that infrared energy, hanging on to that heat. Okay, how does orbital variation affect global temperature? We can take a look at this image and see that Earth's orbit varies from more elliptical to more circular over time periods of about 100,000 years. The orbit is affected by the Moon, the Sun, and other planets. Variation in solar radiation. So that'll be on the next slide. But just taking a look at this right here, you're going to get a variation in solar radiation as far as what is making it into the atmosphere. As the Earth's orbit becomes more elliptical or more oval, there will be points in its orbit where it's further from the Sun and points in its orbit where it's closer to the Sun. This influences climate, but the current global warming has happened in less than 200 years, so it doesn't fit with the 100,000-year track. Okay? The next one is variation in solar radiance. Cosmogenic isotopes in ice cores and tree rings serve as proxies for how the Sun shined in the past, related to solar winds and the Sun's radiance. Proxies indicate the Sun's average energy emissions have varied by about 1% over the last 2,000 years. Changes in solar output and its ability to change climate are still being debated, but it's unclear if this is enough, this 1% is enough to cause the latest temperature